Okay, so in this section, what are we going to look at? We are going to see where sometimes you may have algebraic terms being imputed into a binomial and how you may have to work that out. Maybe there are some unknown letters that you need to work out in trying to resolve, like unknown letters that are fit in there. You need to probably compare and contrast and find some of those things. That's essentially what we're going to look at under this section. 2 questions will guide us on this path. All right, so let's look at the first question that will be used to address this. Now, find in the ascending powers of x the first 3 terms in the expansion of 3 plus 2x all to the power 6. Giving your answer in the form a plus bx plus cx squared, stating clearly the values of a, b, and c. Let's see. So in this section, as you saw in the problem, we would be seeing how various letters or some bit of algebra is tested in these problems that we find, how some of these algebraic letters appear. And the example that was shown, that was read to you, confirms that. Let's look at the first problem. Now, it says that in ascending powers of x, we want to find ascending powers of x, the first 3 terms of an expansion. And the expansion that we've been given here is 3 plus 2x all to the power 6. And the problem is telling us that after you have expanded this, it's going to give you a plus bx plus c squared. That is, the first 3 terms should be of the form a plus bx plus c x squared. And we are told that we want to clearly state the values of a, b, and c. That's what happens. Usually in the exam, just try and take that back of your mind, that you always have situations where you have some letters algebra popping up in there and you have to work with them. So let's see how we do that using the same binomial principle, our k term and all that. So first 3 terms, we're going to have our k equal to 1, k equal to 2, and our k equal to 3. That's very simple for us to see. That means that our r will be 0, r will be 1, r will be 2. Okay, so let's go with that. R equal to 0, r equal to 1, r equal to 2. Okay, so we go 6, choose 0 for our first term, then 2x all to the power 0, then 1 to the power 6 because of that. Our second term is going to be 6, choose 1, 2x raised to the power 1, 3 to the power 5. And our third term is going to be 6, choose 2, 2x squared. Then we have 1 to the power, okay, let's just correct that. Okay, so this is 3 to the power 5, so here will be 3 to the power 6, okay, sorry. Then you're going to have 3 to the power 4 here. Okay, so that is it. It's very easy for us to work that out. So basically, you're going to have 3 to the power 6 here, all right? Then you're going to have 6 times 2x times 3 to the power 5. Then 6 choose 2 times 2 to the power 4 times 3 to the power 4. Okay? So you just have to evaluate all that and you have your answers. I'll just leave that for you to try. Okay, so you can just try that with your calculators. 3 to the power 6 will give you the first step. 6 times 2x, then 3 to the power 5. Then you just resolve it and you have your answer. Okay? So just do that. You can just try your hands on it and the answers will be clear for you. Question 2. Find the first 3 terms of the expansion, all into bracket, p plus x over q raised to the power 5. If the first term and the third term are 32 and 720 x squared respectively, find the values of P and Q where they are positive integers and the second term. Okay, so in this second question too, you have another variant of an algebraic problem that we would be required to work out. And the problem says that the first three terms of an expansion, and the given expansion that we have in the problem is P plus X over Q raised to the power 5, okay? And we are being told that the first term and the third term are given us. We've been given the first term and the third term. The problem mentions that the first term, okay, so the first term is giving us 32, and the third term is giving us 720x squared. Okay, and the question is asking us to find the values of P and Q, where P and Q are positive integers. And further, we should find the second term. So we want to find the value of P and Q where they are positive integers and also the second term. All right, so let's try and go through this problem. What do we do? The same principle. You remember your binomial rule, and you just remember your kth term, your r's, you just load them in. So let's go to our first term. So if our first term is 32, let's look at this expression and deduce our first term from that. Our first term implies that our k is equal to 1. And if our k is equal to 1, remember, our r will be one step behind our k, our r will be 0. So how do we work that out? You're going to have 5 choose 0, okay, x over q raised to the power 0. Then our first part p will be equal to 5. So what do we get from that? All that is going to give you p to the power 5. Okay? So the question says that the first term is 32, which clearly shows that the p to the power 5 can be equated to 32. So when you have p to the power 5 equal to 32, and you take the root of it, like the 1/5 root of it, your p is going to give you 2. Okay, that is clear. Because 2 times 2 times 2 times 2, 5 times will give you 32. Sorry, not 35, 32. 32. Okay, so p is equal to 2. Your p is equal to 2. All right, so it says that your third term is 720x squared. Okay, so let's go there and find our third term. How do you find our third term? Remember, with your third term, your k is equal to 3. And hence, your r, which is one step behind your k, will be 2. Okay, so what do we do then? We just go and again use our binomial formula to find that out. This is going to give you 5 choose 2 x over q all squared. Then you have p raised to the power 3. Okay, so 5 choose 2 with your calculators, that should give you 10. Okay, 5 choose 2 should give you 10. Then you're going to have times x squared over q squared times p cubed. Please, this is not point, it's times. Just remember, times. All right, so this means that you're going to have 10p cubed over q squared x squared. That is your third term. Now, when you compare the 10p cubed over q squared, when you make that comparison of this to that, the third term was said to be 720x squared. And when we tried resolving it, we found 10p cubed over q squared, x squared. Just try and compare the terms. When you compare, you realize that, okay, the x squared goes with x squared. That is fine. Then the 720 will be equal to all that you have here. Let me just make a mark around that. So all of that should be equal to your 720. Is that clear? So that's how you always have to try and compare the coefficients in an exam. Anytime you have such an algebraic problem, take your time, resolve it, and do a comparison of the coefficients. The question may not necessarily tell you to compare coefficients, but you have to remember that. Okay, so what do we get from there? We are going to get 10 p cubed over q squared is equal to 720. Since we know our p is equal to 2, we can just slot it there, okay? That's going to give us 10 times p cubed is 2 cubed. What is 2 cubed? 8, okay? All over q squared is equal to 720. So our q squared will be 80, because remember 10 times 8, it's not 10.8. 10 times 8 is 80, all over 720, okay? So our q squared will be 1 over 9. Our q squared will be 1 over 9. And when you take the square root of q, remember the problem said that p and q are positive integers. P and q are positive integers. So if had it not been that condition that the question had given us, a square root of 1 over 9 should have given us either values of 1 over 3 or minus 1 over 3. But here we are under restriction because the problem mentions that they're positive where p and q are positive integers, okay? So when you have that and you get to such a situation, you take your square root, you only choose the positive one. You don't carry along the negative. Okay, so let's go here. Our q will be equal to 1 over 3. Remember, where p and q are positive. So now we have our p being equal to 2 nicely here, and our q is equal to 1 over 3. So the question says that we should find our second term, right? Let's find the second term. All right, so let's try and just find the second term. I'll just rub this one here off. We're trying to find our second term. So remember, it's not difficult at all, okay? Always have your rules at your fingertips. Always have the rules at your fingertips. And it shouldn't be difficult trying to find this out. So our second term means that our k is 2. Our k will be 2. And what is going to be our r? Our r is 1, okay? So let's just try and do a bit of algebra nicely there. See what we get. Okay, so second term. Our k2, our r1. Remember, the k would, let me just mention this, the k would not necessarily be needed in the solutions. But because this is a revision program, for the sake of exam, always write your k so that you don't make mistakes. It just serves as a guide so that the r that you choose will always be right. Okay, it guides you. Okay. So our second term will be 5 choose 1. We are using our r, not there. 5 choose 1. Okay, x, q, raised to the power 1. Then our p to the power 4. So what do we get? What is 5 choose 1? It's 5 times, okay, our x over our q. And we know our q to be 1 over 3. Then our p, 4. Our p is, we got our p to be 2, right? So this is going to give you 2 to the power 4. Okay, so you're going to have 5 times 3x, as you can see, simple algebra, times 2 to the power 4, 16. Okay, so you should be able to resolve this. 15x times 16. You just multiply 15 and 16. The result is just what's going to give you your second term. So this is our second term. Okay, and once again, I'll leave you to be able to work that out, that simple arithmetic of 15 times 16 to just give you the value of your second term. All right, so that is how we deal with the problems that involve the algebra. Don't panic. Don't panic. Most problems that has got to do with the algebraic terms in your examination or in most of the exam problems would have you having to compare coefficients. Get that. You always need to have the back of your mind that coefficients will be required to be compared. So find the appropriate terms and just compare the coefficients. When I say coefficient, you look at the exponent or whatever term that you have been given, pick up all the numbers or whatever letter you have around it, and just compare and make an equation. When you just make that equation, you are done. All the problems there, I'm sure you'll be able to just work it out. And that is how this part also gets done, right?